Hello, today we're going to continue talking about section 4.3, which is on trigonometric functions. Now, if you look at the key concept here, evaluating trigonometric functions at any angle, the reason we learn reference angles is so that we can figure out what a trig function is in any one of my quadrants, quadrant 1, 2, 3, and 4. Now, the reference angle just gets us so that it's an angle in the first quadrant. And then we can use this information right here to figure out whether our value of our trig function, sine, cosine, or tangent, is going to be positive or negative. So the nice thing is we don't have to know what the sine of 145 degrees is. We can use our reference angle to figure out what it is in the first quadrant, and then realize that, okay, sine of 145 degrees is going to be in the second quadrant, but we can use our reference angle from the first and know that it's going to be a positive value. Or say we're going to find the cosine of 120 degrees. But we don't need to know what the cosine of 120 degrees is. We can just know that it's the same as the sine of, or cosine of 30 degrees, but it's going to be a negative answer because it's in the second quadrant. So here's some of the common angles that we need to know. 30 degrees, 45 degrees, 60 degrees. They're the most common, and that way we can use our reference angles in any one of the quadrants to figure out what our trig function is, and then just know that if we look at this information right here, we'll know whether our data or our answer is going to be positive or negative. So let's look at this one right here, cosine of 120 degrees. So if we want to figure out what the cosine of 120 degrees is, we want to figure out what its reference angle is first. So the way we do that is we first figure out what our reference angle is. Well, our reference angle, when it's in the second quadrant, we're going to take 180 minus 120 degrees. And that ends up being 60 degrees. So our reference angle is now 60 degrees. So really what we have to find is what the negative cosine of 60 degrees is. Now you're probably wondering why I put a negative here. Now the reason that is because in the second quadrant, right here, in the second quadrant, which is where we're at right here, our cosine values are always going to be negative. So we can figure out that the cosine of 60 degrees is going to be 1/2, and since it's in the second quadrant, it's going to be negative. So this is my answer. My cosine of 120 degrees is actually equal to negative 1/2. If you check down the unit circle, that would also be the same. Now, in letter B, tangent of 7 pi over 6. Now remember, to figure out our reference angle here, this is going to be in the third quadrant. Well, how do I know that? Well, I know a full half circle is pi. It's pi over radians. So then 7 pi over 6 is going to be a little bit bigger than 6 pi over 6. So what I'm going to do is I'm going to do 7 pi over 6 minus 6 pi over 6, which if you look back is the same as just pi, and we end up getting pi over 6. So now all I really have to worry about is what's the tangent of pi over 6. And in the third quadrant, our tangent is going to be a positive answer. So tangent of pi over 6, if you look back to your table, it's going to be the square root of 3 over 3. Last one, cosecant of 15 pi over 4. Okay, so what I can do here for this one is I have to figure out which quadrant it's in. So if I was going to have, let's say, 16 pi over 4, well, that reduces to 4 pi. So that would be 2 turns around the circle. So that would be essentially the same as 2 pi, which is 1 turn around the circle, the same as 2 pi, which is 1 turn around the circle. So what I'm going to do is I'm going to take my 15 pi over 4 and subtract 2 pi from it. Okay? Making it easier on ourselves, 15 pi over 4 minus 8 pi over 4. I get 7 pi over 4 is my turn one time around the circle. That's what's left after I've gone a full circle. So then to figure out my reference angle, I'm going to take that 2 pi minus 7 pi over 4. So 8 pi over 4 minus 7 pi over 4. My reference angle is really just pi over 4. So that's my reference angle. So now cosecant, when I look back in the fourth quadrant, sine values are negative. So this is going to be negative cosecant of pi over 4. Remember, cosecant is the inverse of sine. That's why I know it's going to be negative. So cosecant is 1 over sine of pi over 4. And so that's going to be 1 over negative, and then the sine of pi over 4 is the square root of 2 over 2. Now to simplify this, let's make our life a little bit easier. I multiply this by 2 first, and so I get negative 2 over square root of 2. Now I can't have square roots in the bottom, so what I'm going to do is I'm going to multiply top and bottom by that square root of 2, so that on the bottom square root of 2 times square root of 2 is just 2, and so I get negative 2 square roots of 2. Okay, obviously that can simplify since there's a 2 in the top, a 2 in the bottom. I cancel those 2's out, and so cosecant of 15 pi over 4 is actually going to be negative square root of 2 over 2. Seems like a lot of work, but it's actually a little bit easier than what we might have to do in the future. Now, example 5. Use one trigonometric value to find the other. It says, let tangent of theta be 5 over 12, where sine is less than 0. Find the exact value of the 5 remaining trigonometric functions of theta. So to figure out the rest of the functions, we're going to need to know what our r is. Now, since sine of theta is less than 0, it means that our angle is going to be a negative number. So we need to know what angle that's negative is going to give us a positive 5 over 12. Well, the way that happens is it means it's going to be in the third quadrant, which means that my y is going to be negative 5, and my x is going to be a negative 12. So that helps us figure out our r, because remember, to find r, it's x squared plus y squared. So I plug those numbers in. Negative 12 squared, negative 5 squared. I get the square root of 144 plus 25, which is equal to the square root of 169, which is 13. So now I know my r is going to be 13. So I need to still find sine of theta. I need to find cosine of theta. I already have tangent of theta. So then I need cosecant of theta, secant of theta, and cotangent of theta. And the numbers are already given. We know x, we know y, and we know r. So sine, remember, is y over r. So my y is negative 5, my r is 13, so my sine of theta is going to be negative 5 over 13. Cosine was x over r, so that would be negative 12 over 13. Cosecant is the inverse of sine. So we're just going to flip my sine. So that's going to be 13 over negative 5. Secant is going to be the inverse of cosine, so that's going to be 13 over negative 12. And then cotangent is the inverse of my tangent, so it's going to be 12 over 5. Last example we're looking at today. It says, as part of a range of motion category in a high school robotics competition, A student programmed a 20 centimeter long robotic arm to pick up an object at point C and rotate it through an angle of exactly 225 degrees in order to release it into a container at point D. Find the position of the object at point D relative to point O. So essentially what they're asking is, what is this point right here where that ball is at point D? So to figure that out, we first look at the reference angle, which is right here. So since the entire angle is 225 degrees, to find our reference angle, this is our point of reference right here, 180 degrees. So our reference angle theta is going to be 225 minus 180 degrees. Easy math says that that's 45 degrees. So my reference angle right here is 45 degrees. So the arm has turned 45 degrees past our reference angle of 180 degrees. Now, we also know the radius of our arm. That's 20 centimeters. So my radius is 20. So if I need to figure out x and y, I'm going to use my sine and cosine values of my reference angle to figure out x and y. Since our reference angle is in the third quadrant, it means that this value down here is going to be negative x and negative y, because in the third quadrant, x and y values are both negative. So that means that if I'm looking at the cosine of 225 degrees, using my reference angle, that's going to be the negative cosine of 45 degrees. So cosine of 45 degrees is the square root of 2 over 2. Since it's negative, it's this. Now, we also think that cosine of any theta is always x over r. So we don't know what x is, but we know that r is 20. So I'm going to take this value right here and set it to this value right here, knowing that r is really 20. So I'd say negative square root of 2 over 2 is equal to x over 20. Now it becomes a proportion problem. So I cross multiply to find my answer. Now I'm going to take that negative square root of 2 and I'm going to multiply it by 20. So negative 20 square roots of 2 is equal to 2x. To solve x, I divide by 2, and I find that x is equal to negative 10 square roots of 2. So that's my x coordinate right there. Now y coordinate, I'm going to use my sine. So remember, the sine value of 225 degrees is equal to the negative sine value of 45 degrees, which is equal to, again, negative square root of 2 over 2. So, I don't know why, but I know that the sine of theta is always y over r. So, I'm going to set r at 20 and set them equal to each other, just like I did before. And so I'd say that negative square root of 2 over 2 is equal to y over 20. Cross multiply again, and I get negative 20 square root of 2 is equal to 2y. Divide by 2, and I see that my y is also equal to negative 10 square roots of 2. So to answer their question, point D right here is at the point negative 10 square roots of 2, negative 10 square roots of 2, in reference to point O.